Welcome. Today, we are looking at measurement and units. This is topic 1 in your SS1 physics series. This is a foundational topic in physics. It is essential for understanding all other topics. Pay close attention. Let us begin. First, let me explain what measurement is. Measurement is the process of determining the quantity of something. It involves comparing an unknown quantity with a standard quantity. The standard quantity is called a unit. Measurement is fundamental to physics. It allows us to describe the physical world. It allows us to make predictions. It allows us to test theories. Without measurement, physics would not exist. Measurement is essential for science, engineering, and everyday life. Now let me explain the importance of units. Units are standard quantities used for measurement. They provide a common language for scientists. They allow for communication and comparison. Without units, measurements would be meaningless. For example, saying something is 10 long is meaningless. Is it 10 meters, 10 centimeters, or 10 kilometers? Units give meaning to measurements. Units are essential for accuracy and precision. They are essential for consistency. They are essential for international cooperation in science and technology. Now, let me explain the SI system of units. The SI system is the International System of Units. It is the standard system used in science. It was established in 1960. It is based on 7 base units. These are the fundamental units. The meter is the unit of length. The kilogram is the unit of mass. The second is the unit of time. The ampere is the unit of electric current. The Kelvin is the unit of temperature. The mole is the unit of amount of substance. The candela is the unit of luminous intensity. These base units are defined by physical constants. They provide a consistent basis for measurement. All other units are derived from these base units. Now, let me explain the derived units. Derived units are combinations of base units. They are used to measure other quantities. For example, velocity is measured in meters per second. This is derived from meters and seconds. Acceleration is measured in meters per second squared. Force is measured in newtons. 1 newton is 1 kilogram meter per second squared. Work is measured in joules. 1 joule is 1 newton meter. Power is measured in watts. 1 watt is 1 joule per second. Pressure is measured in pascals. 1 pascal is 1 newton per square meter. Derived units are essential for describing physical quantities. Now, let me explain the prefixes used in SI units. Prefixes are used to indicate multiples or fractions of units. They make measurements more convenient. The prefix kilo indicates 1,000 or 10(3). For example, kilometer is 1,000 meters. The prefix centi indicates 0.01 or 10(-2). For example, centimeter is 0.01 meters. The prefix milli indicates 0.001 or 10(-3). For example, millimeter is 0.001 meters. The prefix micro indicates 10(-6). For example, micrometer is 0.000001 meters. The prefix nano indicates 10(-9). For example, nanometer is 0.0000001 meters. The prefix mega indicates 10(6). For example, megameter is 1 million meters. The prefix giga indicates 10(9). For example, gigameter is 1 billion meters. These prefixes are widely used in physics and everyday life. Now let me explain how to convert between units. Unit conversion is an essential skill in physics. It involves changing from one unit to another. This is done using conversion factors. A conversion factor is a ratio that equals 1. For example, 1 meter equals 100 centimeters. The conversion factor is 1 meter over 100 centimeters, or 100 centimeters over 1 meter. To convert, multiply by the conversion factor. For example, to convert 5 meters to centimeters, Multiply 5 by 100. This gives 500 centimeters. To convert 500 centimeters to meters, divide by 100. This gives 5 meters. Unit conversion is essential for solving physics problems. Now let me explain the concept of accuracy and precision. Accuracy and precision are important in measurement. Accuracy is how close a measurement is to the true value. Precision is how consistent the measurements are. A measurement can be accurate, but not precise. A measurement can be precise, but not accurate. For example, if a scale consistently reads 5 kilograms for a 6 kilograms object, it is precise, but not accurate. If a scale reads different values each time, it is not precise. Both accuracy and precision are important in science. They ensure that measurements are reliable. Now let me explain the concept of significant figures. Significant figures are the digits in a number that are meaningful. They include all non-zero digits. They include zeros between non-zero digits. They include trailing zeros after a decimal point. Leading zeros are not significant. For example, 0.0045 has 2 significant figures. 4,500 has 4 significant figures. 3 has 3 significant figures. Significant figures indicate the precision of a measurement. They are important for reporting results. They ensure that results are not misleading. Now, let me explain the concept of systematic and random errors. Systematic errors are consistent errors. They occur in the same direction. They are caused by faulty equipment or bias. For example, a scale that reads 0.5 kilograms too high. Systematic errors can be corrected. Random errors are unpredictable errors. They occur in different directions. They are caused by human error or environmental fluctuations. For example, a person reading a scale slightly differently each time. Random errors can be reduced by taking multiple measurements. Understanding errors is essential for accurate measurement. Now let me explain measuring instruments. There are various measuring instruments used in physics. The ruler is used for measuring length. It has an accuracy of about 1 millimeter. The measuring tape is used for measuring longer lengths. The vernier caliper is used for measuring small lengths. It has an accuracy of 0.01 centimeter. The micrometer screw gauge is used for measuring very small lengths. It has an accuracy of 0.001 centimeter. The stopwatch is used for measuring time. It has an accuracy of 0.01 second. The balance is used for measuring mass. The thermometer is used for measuring temperature. The ammeter is used for measuring electric current. The voltmeter is used for measuring voltage. Each instrument has a specific use and accuracy. Now let me explain how to read measuring instruments. Reading measuring instruments requires skill. First, ensure the instrument is calibrated. Second, read the scale carefully. Third, estimate the last digit. This is called interpolation. For example, if a ruler has millimeter markings, you can estimate to 0.5 millimeters. If a thermometer has degree markings, you can estimate to 0.1 degrees. Reading instruments correctly is essential for accurate measurement. Now let me explain the importance of measurement in physics. Measurement is important for several reasons. First, it allows us to describe the physical world. We can measure length, mass, time, and temperature. Second, it allows us to test theories. We can compare predictions with measurements. Third, it allows us to make predictions. We can use measurements to predict future events. Fourth, it allows us to develop technology. Measurements are essential for engineering. Fifth, it allows us to communicate. Measurements provide a common language. Measurement is the foundation of physics. Now let me give you sample exam questions. Define measurement. Measurement is the process of determining the quantity of something. State the SI base units. The base units are meter, kilogram, second, ampere, Kelvin, mole, and candela. Convert 5 kilometers to meters. 5 kilometers equals 5,000 meters. Distinguish between accuracy and precision. Accuracy is how close a measurement is to the true value. Precision is how consistent the measurements are. Explain the importance of units. Units provide a common language for measurement. They allow for communication and comparison. Let me summarize. Measurement is the process of determining the quantity of something. Units are standard quantities used for measurement. The SI system is the international system of units. The base units are meter, kilogram, second, ampere, Kelvin, mole, and candela. Derived units are combinations of base units. Prefixes indicate multiples or fractions of units. Unit conversion is essential in physics. Accuracy and precision are important in measurement. Significant figures indicate precision. Systematic and random errors affect measurements. Various measuring instruments are used. Measurement is the foundation of physics. Practice these concepts. When you have them down, move to Topic 2.